Hello everyone, this is your code friend. Welcome to yet another video in my YouTube channel. So in our previous video we saw how to read data from different kind of files into a Pandas data frame, and we also saw what are the different ways of creating a data frame. Now in this video we are gonna see some basic data manipulation or some basic data analysis using DataFrame. So these are the things we are gonna perform. We are gonna check the shape of the data frame. We are gonna check the name of the columns, the index values, the first n rows, the last n rows. We are gonna check some basic info like how many null values are present in each and every column, and we are gonna see some basic statistics of every column. And we are also gonna use the set index method to set a particular column as the index of the data. So without wasting any time, let's get started. Okay, so in order to save our time, I have already written this code. So I have already imported the data from the COVID data set from the covid data.csv to a variable called df. So it is basically a data frame. So let's first print our data frame. So this is our data frame, right? So it's basically showing 86869 rows and 59 columns. Now if you want to see these two numbers, if you want to check how many rows are there in the data frame and how many columns are there, so this is the way to check that. You have to type df.shape. So this property, the shape property of the data frame, basically gives us a tuple. You can see that it has returned us a tuple. So the first value of the tuple is the number of rows, whereas the second value is the number of columns. So in multiple places, when you will work with data analysis or machine learning with Pandas, in multiple places you will need to calculate the length of the data frame, that is the number of rows of the data frame and the number of columns present in it. So this is the easiest way to calculate that. So let's say I have asked you to calculate only the row, only the number of rows. So how can you do that? It's simply you can access the 0th element of this tuple, right? This is a tuple. So this is a 0th element of it. If you run this code, it will give you the number of rows. So similarly, instead of 0, if you give it 1, it will give you the number of columns. So this is one thing. This is the way you can calculate the number of rows and columns. Now let's say you want to check the structure of the data frame, or you want to check the first 5 rows of the data frame. So for that you have to write df.head. So it gives you the first 5 rows of the data frame, right? Now instead of 5 rows, let's say by default, if you don't pass anything inside the head function, it gives you 5 rows. Now instead of 5 rows, if I want to access 10 rows, you'll simply have to pass n equal to 10, right? So it has given you the first 10 rows of the data frame. Similarly, there is another function called tail, which is just opposite of the head function. You can understand that from the name of the function. So what it basically does, it gives you the last 5 rows of the data frame. Again, instead of accessing last 5 rows, if you want to access any other number of rows, let's say 8 rows, then it will give you the last 8 rows of the data frame. Fine. So this is one basic thing that we have done, accessing the first n rows and last n rows. So next we have checking index values. Okay, checking name of columns. We have checked the shape. So checking name of columns and checking index values. Okay, so here if I type df.index and press enter, it gives us range index. So if I convert it to a list, it gives us all the indices of this data frame. Fine. Now let's say I don't want the indices of the data frame, I don't want the index of the data frame to start from 0, rather I want to start it from 1. So what can I do? I can set the index of the data frame like this: df.index equal to range 1 to df.shape 0 plus 1. Now you know that in the range function we have, as the upper limit, we have to pass a number which should be 1 greater than the last number in the list. So here we want to start from 1 and we want to continue till 86869, right? So as the upper limit I have to specify 86870. If you are not aware of this concept, please go back to my playlist on the Python 3 tutorial for beginners and check the videos on list and string and also loop to understand the concept of range. Fine. So if I set it like this, let's press Alt plus Enter and my index has been set. Now if I again print the data frame, you can see instead of starting from 0, now our index of the data frame starts from 1. So this is how you can set the index of the data frame as per your choice. Fine. So we have seen how we can access the index of the data frame, indices of the data frame, and how we can set the index of the data frame. So let's see how we can access the name of the columns of the data frame. It is also very simple. You just have to type df.columns. So if you type df.columns, it gives you the entire list of all the columns present in the data set. Now if you want to access it as a list, you simply have to do typecasting. You have to convert it to a list and you will get the name of all the columns as a list. Fine. Now what is remaining? Info. So it is a very interesting function. If you type df.info, let's see what it gives us. If you type df.info, it actually gives us the number of non-null values present in each column. So in ISO code column, we have 86869, that is all the values are non-null. But if you check the continent column, 82686 values are non-null, which is actually less than the number of rows. So from this we can understand that in the continent column there are at least some values which are actually null, because here you can see the non-null count is actually less than the number of rows. So if you just go through each of the columns, you can see like this: weekly ICU admissions. So here we have only 801 non-null values. All the rest of the values of this column are actually null. So from this, by going through this list, we can actually get an overall idea of which column contains how many null values and which column contains how many non-null values. Fine. So this is a very useful function that the data frame offers. So the next function that we are going to have a look at is df.describe. So let's see what this function actually does. If you press Alt plus Enter, you can see it gives us the basic statistics against each and every column. So it gives us the mean, count, STD stands for standard deviation, min stands for minimum, 25% stands for 25 percentile, 50% 50th percentile, 75th percentile, and max value, right? So if you want to get the 25th percentile, 50th percentile, 75th percentile, maximum, minimum, the standard deviation, average, count, these basic statistics, if you want to get the basic statistics for each and every column, this is the function that you have to fall back to, right? So some of you may not know what is 25%, what is the concept of percentile. So we will discuss this in detail in another playlist. I'm gonna create a playlist on statistics, linear algebra and mathematics required for machine learning. So in that playlist I'm gonna discuss these concepts in detail. What is standard deviation, what is mean, median, mode, and what is the concept of percentile, what do you mean by 50th percentile. All these things I'm gonna discuss in detail in that particular playlist. So we have gone through the describe function, right? Okay. Now let's say you have a requirement that instead of accessing all these columns, you want to access the values of only the first two columns, that is ISO underscore code and continent. So how can you do that? That is also very simple. You have to specify the name of the data frame, and then inside square bracket you have to pass a list containing the name of the columns that you want to access. So we want to access ISO underscore code and continent columns, right? So if you run your code, it gives you only those two columns, right? So in this way you can retrieve only a subset of columns from your entire data frame, right? Now let's say you want to add a new column to your existing data frame. How you can do that? That is also even more simple. So let's say the name of the new column is new underscore call. So this should not ideally be the name of a column. It should have a meaningful name, but just for the sake of it, let's accept this name for now. Now you want to create this new column by subtracting the new dates from the total number of dates. So how can you do that? It's again very simple. df total underscore dates minus df new underscore dates. Fine. So let's try to run this, and it has run successfully. Now if we again print our data frame, and if you just scroll to the rightmost part, you can see a new column called new underscore call has been added. Fine. So this is how you can add a new column in your data frame. Okay, now let's say we want to set the date column as the index of the data frame. Instead of taking 1, 2, 3, 4 this integers as the index of the data frame, we want to set the date column, the values of the date column as the index of the data frame. Now how can we do that? Now one way to do that is very simple. df.index, just as I mentioned earlier, df.index equal to list df date, right? Let's try to run the cell. It has run successfully. Now if we check it, you can see the dates have been set as the index of the data frame. There is another way to do this, and that is df dot set underscore index, and inside this, in the list, you have to pass the name of the column that you want to set as the index of the data frame. Okay, so let's go to this. Yes, you have in the keys, you have to actually pass the name of the column that you want to set as the index of the data frame. There is another parameter called in place. So this parameter is very important, guys. If you set this parameter to true, then the existing data frame df itself will be modified. Okay, so let's set this to true. Okay, before doing this, let's reload our data frame for once, because otherwise you will not be able to understand or recognize the changes. So our main data frame was like this, df. Let's run this. Our main data frame was like this. Now what we are trying to do, we are trying to use the set index function to set the index of the data frame as the date column. Okay, so let's run it, and if you print the data frame once again, you can see the date column has been set as the index of the data frame, right? Now what would have happened if I made this false? So again, let's first run this cell. So this was our original data frame. Now this was our original data frame. Now you make it set index in place equal to false. Fine. So df.set index in place equal to false actually returns you a new data frame after setting the date column as the index of the data frame, but the original data frame itself, that is the data frame df on which this function was called, will not be modified. Let's check that out. If we run df from here, you can see the original data frame has not been modified. It has actually returned us a new data frame with the desired result, but the original data frame was not modified, which we could see from this cell, right? So in place, what does this in place parameter actually do? If you set in place equal to true, then no new data frame will be created. Rather, the original data frame df itself will be modified. Whereas if you set in place equal to false, then no change will be done to the original data frame. Rather, a new data frame will be returned. So let's make it true. Now if we reprint our data frame, you can see the original data frame df itself has been modified. So that's what the in-place parameter does. The value of it decides whether the original data frame itself will be modified or a new data frame will be created with the desired results. Fine. So that's it for this video, friends. In this video, we have gone through some basic data manipulation in Pandas data frame. In the next video, we will look at some more data manipulations using data frame. So if you have liked my video, please let me know that in the comment section. It will encourage me to make more videos on Pandas, NumPy, Matplotlib and the other data analytics related libraries. And if you have liked my video, please don't forget to share my video so that it reaches a larger audience and they also get benefited from it. Thanks a lot for watching.